Hello, everyone. Welcome. This is October 1st, 2021, and it's a Friday. This is our next YouTube stream, and my name is Levent Gürdemir. I'm astronomer at UTA and the Planetarium Director, and here is in the office with me Jim Bader, Program Coordinator of the Planetarium.
Hey.
And as we promised, we said we are going to be here Friday noon, and we are here. If you have any questions, use the chat to interact
Definitely.
with us, and please put down your questions so we can answer. And I know people are asking a lot of questions. We get tons of questions during the week to our Ask Astronomer portal, to the planetarium email, and sometimes to the social media. And some of the questions are actually really, really good questions.
Oh, we have Lamia's. She's watching. She's cross-watching. Thank you so much.
Great. So we have some, I think, people from Facebook too. Facebook viewers are also coming here. Great. So before we start, I would like to show you a few things in the sky, but also I would like to address some of the questions that we received. And I think Jim is preparing me some questions too. So what's on the list, Jim?
Well, we had only two questions that I found that I thought were worthy, and I got to be honest, I'm a little nervous for how you're going to answer these on the fly. I mean, these are pretty good questions.
Okay.
A little nerve-wracking. Let's just do one, and then we'll do some sky talk. Is that okay? And then we do the second one.
All right. Yes,
if we
sounds
have
like a
time?
plan.
Okay, sounds good. All right, so what non-Earth natural disaster is most likely to happen? And then they go on to clarify with some bad grammar, I think, gamma ray surge, in quotes, CME, and some other stuff that was a little more terrifying. Doesn't need to be specified, I suppose.
Well, people are always expecting a big version of this coming and hitting our planet, splitting into two. It was on the news the other day. I seen another title said like, or just missed or something in lines. It was talking about another asteroid, which is like, the 3 times of the size of the Eiffel Tower in Paris. And when they say just missed, that's the funny part, because they talk about like 250 million kilometers or something like that.
I don't know if you saw, I think Brexton sent us an article about that on Facebook.
Yeah, I remember. And the distance was close to like 1 million kilometers. So 1 million kilometers, actually, when you think about it, it's a lot, because it is about 4 times the distance of Earth and the moon. Well, in fact, the Earth and Moon distance is actually not quite close. Sometimes you see in the pictures they put Earth as a round planet and just next to it the Moon, and the size is actually not accurately scaled, because the Moon, if you like, for example, you cannot fit Earth and Moon scaled on a piece of paper. So you need larger paper, or you need to maybe lay down 3-4 papers together, so you can exactly represent the size of the moon and size of Earth and the distance in relation. So it's quite far usually. Let's talk about gamma ray surge and CMEs also, that was asking the question.
I have a cool picture, I think, that represents just the vast distance between the moon and the Earth, which I think is I think it's worth bringing up. So let me grab it here and drop it onto the screen for you.
Yeah, while you are searching on that, the gamma rays are some type of cosmic rays, they are coming from space as we speak. And the intensity of those are not sufficient enough to do a DNA damage. But if it goes up, and I think the surge means, but if the intensity goes up, we get plenty of it. Yes, I mean, it may affect the life and as basically DNA on Earth. So would they surge? Well, could be, but the possibility is low, because the gamma rays, while we do not know the exact origin of all the gamma rays we are getting exposed to, we know some gamma rays are originating from fast rotating stars. The fast rotating stars, especially if they are like, the neutron stars and pulsars or and black holes, or when the stars become supernova, when they explode at the end of the lifetime, that releases a shock wave, and in like one, actually two specified direction, they release gamma rays. So, and that direction is along the rotation axis of the object of the star. They release gamma rays. So the star's rotation axis, if it is just pointing down Earth very precisely, they may send all the gamma ray bursts to our planet. But
That is
what is the
terrifying.
potential that the Earth axis, the rotation axis of the star, before it explodes as a supernova, is pointing Earth directly? And remember, like, Earth is a moving object. It orbits around the solar system. The sun is also not a stationary object. It is also flowing with all the stars in the Milky Way galaxy. And the stars, when rotating, they may be wobbling and changing the rotation axes, and so on. So potential is there, but low.
Yeah, it's
so we are looking at the planets.
Yeah, this
right?
is actually a relative size
Uh-huh.
comparison. I mean, it's not incredibly accurate, but it's showing the distance between the Earth and the Moon.
I
It's
think
so
I
big.
remember this planet.
Do you?
I'm sure I've seen it somewhere.
I don't know. I don't know. But you could actually fit all the planets, all the other planets in the solar system between the Earth and the Moon. That the distance is huge.
Yeah.
And 1,000,000, 4 times this is obviously that's not close.
At our campus, the astronomy labs are located in a building called Science Hall, and it has a long hallway. And more than a decade ago, my students made drawings of the planets in a scaled model on the walls. It's still there. It's pretty cool. So they painted all the planets murals, and they made it in a scale way that the sizes were right, but also it covered the entire hallway to fit all the planets, starting from Mercury all the way to Pluto, which Pluto was considered a regular, or let's say rocky midget planet, terrestrial planet back in then. And finally, CMEs. CMEs are coronal mass ejections. There's a corona word. Yeah, you heard it right. Corona is actually not only the name of the disease, but also the outer layer, or let's say atmosphere of the sun, our star. It's also called corona. And there's a lot of things going on in the corona layer. There's a lot of material sometimes being ejected, and usually they are in the forms of fireballs. So it's, if you look at in detail to the surface of the sun, it is just like a boiling water. And sometimes that boiling water pops, and it pops giant fireballs, and they spread into the entire solar system. Those are called coronal mass ejections.
Here's an example.
Here's an example. You can see it's a great example. So here's the sun. The sun's surface is covered by a mask by the telescope. This image is coming from SOHO Satellite Observatory. So the sun's surface is covered because it is so bright. It is just saturating the camera if we don't use the mask. But around the sun, this is the corona layer, and we can see all the ejected material. And this happens pretty quite often. So is it dangerous? Yes, it's dangerous if Earth, it just leaves the sun, and coincidentally it is aimed to Earth, and if one hits to Earth, the smaller ones are not big problems because the sun has a invisible protective shield around it. It's the magnetic field. So these streams are containing highly charged particles. So highly charged particles are, that means that they are carrying electric charge. When they get close to Earth, Earth has a magnetic field around it. So the magnetic field diverts the electrically charged particles, and it actually breaks the fireball and throws it in the space, which is a great mechanism, great protection mechanism. But the size of the fireball is huge. Yeah, it may cook Earth.
So I wish that I could pause this image, because right as this explosion, the ejection happens, you can see that like bound magnetic field break. You can just for a moment, you can see it like, hey, it's a closed ring, and then it just pops right as I mean, this is such a perfect example of what a CME is, really.
Yes, yes.
Which is why I found it from NASA
It was,
so quickly.
I don't remember exactly, but 5-6 years ago, a huge coronal mass ejection happened from the surface of the sun, and it crossed Earth's orbit. Fortunately, Earth was not there at that time. But if the timing was, again, I mean, things can happen. It all the matter of timing. If you are at the wrong place, and this is true for our life too, right? If you are at the wrong place, wrong time, you may be in trouble. So I hope that answers this question.
Well, I think the question, and I'm not sure if you answered directly, but which one of these do you think is most likely to happen?
Coronal mass ejections are likely to, happen. I mean, there's this potential is small. The risk is small, but also as the same risk is coming from these. Those are all over the place in the solar system. Unfortunately, they are close, as the solar system has evolved to a major state, and in that state there is not like free floating dangerously big particles, but who knows? I mean, the one thing is they may be small, but by physics they are traveling at very high speed, very fast speed. So by physics, the momentum is related to the speed and the mass. Mass may be small, but the speed may be big. In this case, they are still destructive. All right, so some of the questions from I see from Lamia asking, are CMEs predictable? They are not predictable. They are actually happening pretty frequently. We cannot tell when it is going to happen, but we can statistically say, per day, per month, per week, the number of the CMEs are occurring. We can certainly see one after one releases from, because as Jim showed, the satellites, the real image, real video, there is a satellite 24/7 continuously monitoring the sun. They are predictable in one way. There is a solar cycle. At every 11 years, the number of spots on the sun goes down, and then the visible number of spots goes up, and this cycle takes 11 years to complete. We don't know the exact reason why it is 11 years, but it is 11 years. We just realized that the sun is more active and likely to show more coronal mass ejections when there are more and more spots on the surface of the sun. And because we know the sunspots are related to the magnetic field, and the coronal mass ejections are also magnetic field activities, so this makes sense. So number of the spots increase, the coronal mass ejections increase.
It's important to note that we did already have on one of our shows Dr. Welling, who studies this stuff directly. So maybe it's time we get him back on the show. And
yes,
do another...
especially he can comment on rapidly changing the magnetic axis, not the actual rotation axis, but the magnetic axis of the planets, the Earth. He says it is rapidly changing.
Yeah.
shifting.
He was an interesting guy. One of our best live streams for sure. But maybe it's time we get enough stuff
I
and
think
bring
yeah,
him
we need
back.
to bring him in.
I think so. All right. Let's go ahead and just do a sky update. What's going on in the sky?
All right.
That's the show. So I'm gonna move you to over to Digistar.
October Sky has a great show. There's a movie, right, called October Sky. It's not about the sky, actually. I'm going to tell the actual sky part, but you are welcome to watch the movie. So first thing you can notice, right after sunset, you can see a very bright object that we actually last week we talked about it, right? It's Venus. Don't think it's an airplane or it's a UFO. Venus is very bright, hanging in the west direction right after sunset. So let's turn the sky to west direction and you can see Venus. And when you find Venus, it is going to be, let me do some corrective controls over here, because I would like to show the horizon and how high in the sky. So this is your horizon and the Venus is going to be that high in the sky. It is going to be very bright. When you find Venus, you see like bright stars. That's great. So
this is about 8:07 p.m.
Yes, the sunset is about 7:15. So it's getting very early. During summer, we had like 9 p.m. Sun settings. Not anymore, because we passed equinox and days are getting shorter and shorter. Here is Venus, and when you find Venus, you can find some bright constellations too. Right, just on the left side of Venus, you can see 3 bright stars and a string of stars. It's going down and making a turn like this. So this is constellation Scorpius. It actually looks like a scorpion. You need to use some imagination to find the scorpion. But it is very easy, you can find. And here is at the center of the scorpion. This star is called Antares. Antares is a red star. It's a red supergiant. You can really notice the red color if you are looking into it. So very easy to find constellation. Located just left of Venus. You can also, this is not a zodiac talk, but here we talked about zodiac constellations because that's why I'm mentioning. You are going to see like 2 stars, like about equally bright. So equality, does it tell you anything? If you think about the zodiac constellations, the constellation Libra. Well, the other 2 corners are very dim stars, so it is not easy to see, but you can certainly see these 2 bright ones. And the stars have cool names though. One is called Zubin Shemali, which is located on the above the constellation, and on the bottom one called Zubin El Janabi. So the names are coming from the Arabic language, and the constellation Libra represents balance in the sky. Why it represents balance? Actually, it's another great history. Back in time, about 5,000 years ago, when these constellations and stars were named, the equator, the ecliptic was actually just coming across, the equator was coming across the constellation between these 2 stars. So one of the stars seemed like it was sitting above the equator in the northern hemisphere. Another star, Zubin al-Janabi, seemed like it was sitting below the equator line, which is in the southern hemisphere. So these stars were just divided by the equator, represented balance on the equator line. So that's why the constellation was called Libra, the scale. So it looks like the scale and a balance. All right, so there are plenty of stars, and maybe it's a great opportunity to talk about the North Star. So North Star is very easy to find if and only if you can identify the Big Dipper constellation. I can immediately see this great constellation in the sky, and you can do too. Let's go down a little bit in our horizon, and you cannot see and find directly North Star unless you have like a lot of sky watching experience, which can be done. But my first suggestion is find this easy constellation first. It is called Big Dipper. Well, it really is in the shape of a big giant spoon in the sky. It has another name called Big Bear. Well, it is a little bit more difficult to imagine bear, but you have to just imagine a tail over here and a head and legs and so on. But let's go back to the...
There's so many problems with this bear. So many.
Well, one of the problem is the long tail, right? When was the last time you've been to the zoo and look at bears? I do all the time, and their bears are never long because bears have short tails. I don't know who imagined long tail in this, but here is, I use the Big Dipper part, okay? So, okay, let's go back to the North Star. North Star is not here in this area. It's in this area. So I use these two stars of the Big Dipper. Those are called guide stars or pointer stars. So you have to guess the separation of the two, and we will go in this direction 5 more times, okay? 3, 4, 5. And here, this star is the North Star. It's easy to find if you use guide stars. The separation of the guide stars, follow 5 times, and you will find the star. It's not very bright star. It is, especially if you have too much light pollution in your area, you may not be able to even see it. And if you don't have light pollution in your area, it's going to be bright enough to be visible. And it is also the part of Little Dipper constellation. A Little Dipper starts from the North Star. It is the exact opposite version of the Big Dipper. It is also called Little Bear. So let's see that Little Dipper constellation stick figure. So you will know what I mean, why it is called Little Dipper or Little Bear too. North Star is an important constellation, important star, and because it points us the north direction. So simply, you look at North Star, you are facing north direction. It is very easy to find other directions, so you can use it for navigation. You do not use, or you do not need your expensive phone to find directions.
Before we jump to the comments and questions in the chat, I just want to point out something that drove me crazy as a child, and even as a young adult. The constellations of the Big Dipper and Little Dipper, both dippers, but you can't really see the Little Dipper in our backyards, right? It's super dim. Mm-hmm. You got 3 stars, but the Big Dipper shines pretty bright, even in many heavily populated areas. So not always. Dallas is one of those where it's pretty difficult to see the Big Dipper from downtown, but still can't see the Little Dipper very well.
Yeah, there was a list of the worst skies of the United States. Certainly the New York City, Manhattan made the number 1, and they measured the worst rate of the sky with the number of stars visible, and in the New York City it was only 2. Dallas-Fort Worth area was a lot better 10 years ago, 15 years ago, but now we have too much lights, especially those like the bright LED lights. LED lights are great, low cost, economically, that makes sense, but they are good about also replicating the daylight, because they are like the heat temperatures, or just the light temperatures are they can be very close to the one to the sun. So sometimes on the boxes you see the daylight labeling on those. They are causing a lot of light, so they are bright, they are making a lot of light around, so we cannot see stars pretty well. You can still find directions, right? Using this technique, you can easily find north, and just you need to find, you need to just remember that if you are looking at the north direction, your left hand is going to be west, and your right side is going to be east, and the back side is going to be south. You can also find one important marker, or your address. with North Star, and that is, the GPS gives us two coordinates. When you open up your phone immediately knows where you are, and it just makes like a point marker and drops it on a map and show you where you are exactly. So how your phone is doing that? It is getting two coordinates from GPS satellites, and according to that, it marks your location. So one of the coordinate is your latitude. The second coordinate is your longitude. How can I find my latitude? By looking at North Star. So look at North Star, and you can either estimate, or if you have a device called sextant, you can measure the distance between horizon and the North Star. So if you do that from Dallas-Fort Worth area, you are going to find a number very close to 33 degrees, because that is where we are located, which latitude we are located on Earth. So the North Star is not going to change its location through the night. But if you go to different place, especially if you move to north or south on the hemisphere, Earth's hemisphere, for example, if you travel to Canada, you will find that North Star is going to be higher and higher in the sky. If you go to Mexico, you will find out that North Star will get lower and lower in the sky. If you cross the equator and if you go to southern hemisphere, you will no longer see a North Star in the sky, because it's not going to be visible from southern hemisphere. This is how we find our longitude, the latitude. Can we find our longitude? Not with North Star, but there are some tables that the people used for celestial navigation for thousands of years. How did you think the people migrated all the way from Europe to the United States? The GPS was not even invented back then. Certainly there were no like, fancy touch screen, not even touch screen. Even with the knobs, navigation devices did not exist. All people used were the stars. And yes, there are some tables that contains the meridian passing times of the bright stars. So if you identify a bright star close to the meridian, which is the highest point in the sky, and then you can tell by looking at the tables at which date and time that particular star reaches its highest location in the sky. So you can find out your longitude too. So it's pretty cool. You can use the information from sky, and you can find your GPS coordinates. You can find directions north, south, east, west. Also, it can be viewed through Cassiopeia, I remember. North Star?
Yeah, she's saying
North Star.
you could use Cassiopeia to
Oh,
help find the North Star also.
Right. I was just misreading the question, or just part of the question. Yes, Cassiopeia can also be used. All right, so great questions too. We have one more cool thing in the sky that I would like to slightly talk, and that is summer triangle. And summer triangle is very popular, and at this time of the year, well, I know it's already past summer, but this constellation, or this summer triangle feature, is not actually only visible during summertime. It is very high in the sky. Summer triangle is not a constellation. Every corner is a different star. Each stars belong to different constellations in the sky. And the summer triangle, I like it because I can find very cool objects in it. Here is the constellation, the Cygnus the Swan, and here is the constellation Aquila, and here is the constellation Lyra the Harp. So in the Lyra, the bright star is called Vega. Vega is a cool name, and Vega is also a star that is very looking like our sun. You can always, like, they are like two sisters or two brothers or twins. So the sun, this is a sun-like star.
It's also only like 25 light years away, right? It's pretty close.
Yes, it is pretty close. Of course, distance makes a lot of difference in the brightness and all the energy that is coming towards us. The Cygnus constellation, it's called Flying Swan. But the most important thing about Cygnus constellation is the first discovered black hole is located in this constellation. And it is named as Cygnus X1. And why it is X1? Because it is X, we got X-rays from this object. So we didn't know what a black hole was, or even they existed. But there was like a strange X-ray radiation coming from a point in the Cygnus constellation. So they named it as Cygnus X. And because it was the first one, they called it X1. And it turned out to be first discovered black hole. And in the Lyra constellation, I always like pointing a telescope somewhere around here because there is a dead star located. It's a nebula. It's called Ring Nebula. A beautiful, colorful rainbow of colors rings. So this particular object, let's you are okay putting identifying marker on the Cygnus X1.
That was really delayed. I hit that a long time ago.
All right.
I thought it went off. I'm sorry.
Yes, the Cygnus X1 is located right here. You do not need to try to see it because there is nothing to see. The black holes do not reveal themselves because not even light go out of the black holes. So no light is coming to you. You are not going to see anything. But the other one, Ring Nebula, is not that way. It is a wonderfully colorful object, and it's a dead star. Some stars die this way. Some stars become a black hole, and some stars just become a nebula, which is cool. All right, so I think my time is up, and I need to go. But if you are still interested in hearing more about these objects, celestial events, and even if you have your own question, please let us know. Come back here next week. We are on Facebook on Wednesdays and YouTube on Fridays.
Yeah. All right. I guess that's it for today, right? Thank you guys so much for viewing.
All right, great. See you next week.
All right.